Quadratic transformations. So, when we talk about quadratics, quadratics are going to be some equation that has a squared. So because I see this squared, I know it's a quadratic function. And because it's got the squared, the graph will be shaped like a U, which we call a parabola. Each of these letters, A, B, H, and K, represent some sort of change that happens to the parabola. So the important things to remember are which ones are vertical and which ones are horizontal. So when we talk about A, B, H, and K, vertical adjustments are going to be on the outside of the parentheses. Whatever's on the outside is always going to tell the truth, meaning if you think like that is going to happen, then it probably will. What that means is that the letter A and the letter K are both vertical shifts. Then the horizontal is going to be the opposite, meaning that it's on the inside of the parentheses, and if it's on the inside of the parentheses, it's going to lie to you. So what you think is going to happen is actually not, it's the opposite. So we have to be careful when we use the letters B and H to find out what they represent. Let's start with something vertical, like the letter K. At the very end, this is honestly, I think, the easiest thing to identify because it's on the outside at the very end and it tells the truth. So if it's on the outside, we mentioned that it was a vertical sort of shift. So K could be positive or negative. If it's positive, then the parabola will move up. And if it's negative, the parabola will shift down. So up and down are going to be on the outside, which means left and right are on the inside, represented by the letter H. The letter H could be positive or it could be negative. And so remembering that the inside lies to us, if it's a positive, it's going to move left, even though it usually moves right. And then the negative will move right. Now that we've taken care of moving the parabola up, down, left, and right, and that means we're just translating the exact shape up, down, left, and right, we have two other letters, A and B, that we need to know what they do. So taking a look at the A value first, because it's on the outside, it's going to tell us the truth. The A value could be positive or negative. Now, if it's positive, we don't really need to note anything, because it's still going to keep what it is. But if it's negative, then it's going to be reflected over the x-axis. Which means that instead of opening up like a parabola normally does, it's going to open down and have a maximum point with the U at the top. So that's if it's negative. But we're going to separate that from the actual number. So if the actual number of A is greater than 1, it's going to be vertical since it's on the outside and stretched. When I say vertical stretch, I mean imagine holding the parabola at the bottom and at the top and pulling it away from each other, your hands away. So then that means that this parabola is getting skinnier, it's getting narrower. And so that's what a stretch is. So then if the A value, not including the negative, is between 0 and 1, it's still going to be vertical because it's on the outside, but this time it's a vertical compression. A vertical compression meaning if you hold the parabola at the top and at the bottom, and then you push your hands closer to each other, then that would be making the parabola wider or fatter, so that way it's compressed. So those are all of the things for the A value. The B value is going to be the same, but opposite. So the B value has a positive and negative, and so if it's a positive, we don't need to write anything, but if it does have a negative, then we're going to say that it's reflected over not the x-axis, but the y-axis. So then, taking the numbers separate from the positive or negative, if the B value is greater than 1, it's going to be horizontal because it's on the inside, And this time, it's not going to be a horizontal stretch like we would think in our minds. It would be a horizontal compression. So imagine taking your hands on the left and right of a parabola and then compressing it, meaning pushing your hands together. This parabola is now getting skinnier and narrower as it goes together, kind of like a vertical stretch. So then similarly, we're going to have one more thing about horizontal for the b, and that's if the b value is between 0 and 1, it's going to be called a horizontal stretch. And this horizontal stretch is going to say if you take your parabola on the left and right with your hands and then stretch your hands out away from each other, then this parabola is getting wider or fatter. So then it changes the parabola in that way. So let's take a look at one example. Here we have an equation with a quadratic function because it's got this squared, so we know it's quadratic. So now we're going to take a look at what each of these things means. So starting at the end, I'm going to look at the k value, which is 6, and that k value is on the outside, so it's a vertical thing, and so it tells the truth, meaning it's up 6 units. Then taking a look at the inside, going backwards, we have a horizontal shift of 5. Now remember that it's on the inside, so it's the opposite of what you think. So if it's a negative, we're going to move right 5 units. Then I'm going to go to the front and see something at the very front of this quadratic function. So taking a look at the 3, that 3 is going to be a vertical shift. Now it's a positive, so I don't need to write anything saying it's reflection or not. But there is a number, and since that number is bigger than 1, we're going to call it a vertical stretch. If it's a vertical stretch, that means that it's going to be skinnier than the normal U shape. Then our last piece is this 2, but it's not just 2, it's a negative 2, so that negative tells us something. It tells us that it's reflected over the y-axis. But then the 2 tells me something else. That 2, since it's bigger than 1, because we're not including the negative sign, that 2 tells me that it's going to be a horizontal compression. Because usually we'd think of a number smaller than 1 as a compression, but since it's on the inside, it's lying to us. So this quadratic function, if we were to start from the original parent function x squared, it would have these 5 different things that transform it into its current equation.